Madison,
Wow.
Wisconsin.
And all right, I am so excited for today. If y'all couldn't tell, I'm a little space obsessed. But before we get started talking all about space, Vinny, tell us a little bit about yourself and your internship here at Microsoft.
Yeah, for sure. So, yeah, I'm an intern at Microsoft. I'm a program manager intern. I'm studying computer science at Wisconsin-Madison right now. So it was awesome to apply what I learned to Microsoft. And yeah, over the course of my internship, I got to work on a really cool project, which was, integrating space with learning. So I made a bunch of different learning paths on Microsoft Learn that are going to be debuting on Thursday.
So
To
exciting.
Yeah, made for like all beginners. Everybody's welcome, and you'll just learn machine learning, artificial intelligence, and some introductory to Python. All with a nice space context.
I'm so excited. So you and I connected over our shared love of space.
Yeah, and Clippy.
And Clippy, of course, if for all those Clippy fans out there. Now, I have had the very extreme pleasure of attending 2 NASA social events. I've got my very special rocket ship that says Chloe on it here because it's so rare to find anything with the name Chloe on it. But for those who don't know, NASA social events, before social distancing, of course, were these really awesome events that you could attend, see all sorts of cool things. Like I saw my first rocket launch in Florida, which was, oh my gosh, so incredible. And I also recently, earlier this year, went to NASA Armstrong with a fellow cloud advocate,
Wow.
April, and we got to learn all about these Earth science missions. So learning about space in the last year has been really fascinating to me because I think for a lot of us, and correct me if I'm wrong here, Vinny, because I feel like you felt the same way, like NASA and space can feel like this super far away thing that people in lab coats that smart people do.
Yeah.
Like it feels very unattainable. But what I learned from these 2 events that I went to is there's actually ways to get involved with NASA projects in very simple, kind of open sourced ways.
Yeah, for sure. Yeah, I mean, space is super far away, so we gotta do whatever we can, and NASA really has brought it as close as it can be, with their different like museums and sites you can go to, as well as they have some learning of their own on their web pages, and also just all like the open source pictures and projects that you can work on, or just take a look at different moon rocks from space.
And we're gonna get into that really today.
Cool. Yeah, for sure. And it's just like such a great time for space because like the SpaceX launch, and NASA's launching the Artemis rover in 2024, and the Perseverance rover just launched I think a few weeks ago. So all exciting stuff.
Now, you made these awesome Learn modules that we're going to get into in a second here. But one of your Learn modules I could have personally used myself because for this particular event, this launch, we saw the SpaceX CRS-18 launch, which I will tweet out a video of later. It's just me being very excited watching a booster land back down where it's supposed to. I became a NASA nerd like instantly as soon as I saw my first launch. But delays in launches are so something that I learned at my first launch the hard way is you never know what the weather is going to be, and weather has a very big factor, I should say, in the success or even if the launch happens. And you built this Learn path that actually helps us predict what the weather is going to be. So where was this Learn module when I needed it, Vinny?
Yeah, I know. I should have, put it out to everybody for the launches. But yeah, that's what really inspired me to build it was, I don't know if you guys know, but the SpaceX launch, it got delayed a few days because of the weather. So when I was thinking of, different ideas, like what would be really cool to build with artificial intelligence, I thought about that. So yeah, and there's just so many things that go into a rocket launch. And, that's why you see these delays more than like, a flight, for example. Like the rocket is literally like when it launches up, it attracts lightning to it. So the conditions, need to be perfect. And the lightning, there needs to be like not a lot of electricity in the area, or else, lightning will just trigger it and strike the rocket, and that's no good. Little Barbie would not enjoy that.
Not enjoy. I've got my space Barbie here that I got when I was at Kennedy Space Center, joining us today on the live stream. Yeah, and something that I also realized, well, I will say one of my favorite memories of seeing a rocket launch live was myself and a bunch of other NASA social attendees all just blowing at the clouds. It would actually help move the cloud coverage away. But when we think about, how many things have to align perfectly for these launches to go well.
Yeah.
Not only do we have to launch the rocket off into space, but the booster has to come back down and land successfully on a very, very small amount of space. No pun intended, space. But another cool thing, and I'm not sure if one of your Learn modules touches this, is there is actually a lot of, I think when we think of space, we think of the moon and the stars and, launching into space. But a lot of what NASA does is research on our own planet, Earth, for those of you who, maybe
I forgot what planet.
But there are so many open source libraries and projects and things that people can be building with the information that we get from the Earth. So the second NASA social event that I attended, myself and April got to learn quite a bit about how we are studying the world's oceans, how we're studying cloud coverage, and beyond using a rocket ship, using these very high-tech airplanes that are often used in the Air Force to go into special altitudes to be able to measure those things, and special boats that are sent out to measure, the different sea levels to make sure that the Earth is going to be safe. So first of all, shout out to NASA. We love NASA. Thank you for all the work that you do. And today we're going to dive into these amazing projects that you worked on. So these learning paths are launching pretty soon.
Yeah, they're launching on Thursday. Yep. So we'll throw the links all over when they launch on Thursday, so you guys can complete them all. And they're all folk. We're trying to be really inclusive. So anybody, any skill level, feel free to come and try them out. We're really excited.
Yay! And we got the chance of them below, so everybody can try them out. They'll be on my YouTube, and we can definitely share those with y'all.
For sure.
That's so great. Anybody who maybe even for those folks who are thinking NASA, that's way beyond my skill set, are going to be able to go in, work with real NASA data, and build these cool, awesome things that you made. I'm so excited.
Yeah, and we also are hoping to have some videos of actual NASA scientists introducing you to the lessons. So, you get even a deeper dive into the life of a NASA scientist.
Okay,
get in their shoes.
Before we get started, I have to tell you my favorite thing that I saw when I went to NASA. People are probably thinking, a moon rock, an alien. No. Fun fact, I saw on Twitter today that today is the anniversary of Nickelodeon launching Rugrats, Ren and Stimpy, and Doug. So it should be a national holiday in my opinion.
Oh, yeah.
But Nickelodeon was at Kennedy Space Center when we went there because they were sending slime to space. Yes, that green slime that we see on Nickelodeon all the time, because they wanted to see how space, or how slime, I should say, reacts in space. So there's all sorts of fun, cool projects like how to 3D print things in space. There's all these problems that we're solving all the time. But I will share that picture later. There's a picture of me holding some slime that's going to be sent to space. And
that's before or after it was sent to space?
Before. I'm curious, I have to look up how the slime ended up reacting in space.
Hopefully it didn't come back disintegrated.
But I love anything space related, slime related. So this is right up my alley. And I think you and I talked about, we both didn't get to go to space camp when we were kids, but now we get to work on these Learn modules. It'll be great.
Yep, this is my comeback. So hopefully I didn't go to space camp. Hopefully this could be like a space camp for other people.
We couldn't have our own space camp, so we built our own, y'all.
We built it.
All right. Should we dive into the code here? I'm so excited.
For sure. So I will go ahead and
in the meantime, we've got Space Barbie here. Trying to think of some other fun space facts. Just some funny facts. Our tour guide for NASA Social was in the movie Sharknado. So at NASA, they have a bunch of different facilities there, obviously, like the CAD, which I should know what it stands for. Let's see, CAD.
Oh, geez. I should know too.
NASA. I'm just so used to calling it the CAD. The not cost estimating capability. But there are all these amazing buildings that you'll see in popular pop culture things like I Dream a Genie and movies like Sharknado, where they film at NASA. And apparently a lot of the NASA workers there will get asked, like, hey, do you want to be an extra in this film? And our tour guide happened to be pulled into the background of Sharknado. I thought it was the funniest, because they're naming all these, like, you know, famous movies like Apollo 13, like, and Sharknado. And I'm like, tell me everything about Sharknado. Yes, Space Barbie is here. She's joining the stream. If you haven't watched the 8-Bits interview on my YouTube with Bianca Vasquez, she shows off all of her Barbies, including one vintage, I think it's a 60s or 70s Space Barbie that's definitely worth taking a peek at. Alrighty.
Great. So can you see everything there on my side?
I see.
It should be just an empty Jupyter notebooks. That's where we're starting.
Perfection.
From ground zero.
How perfect. Jupiter is a planet, so
Jupiter, yeah. Everything's related. Cool. So yeah, so I'll just give you a little background before we jump into the code and everything. So this learning path is really all about predicting the launches, as we said before. So we've got a little Excel document here with a bunch of different data from past launches, on some days that the rocket launched and some days that the rocket didn't launch. So we're going to go ahead and use a few different libraries here. We're going to use a scikit-learn here to get our machine learning model up, and then we're actually going to predict on a future day with like these given conditions if the rocket will actually launch or not. Nice. So yeah, it's going to be really exciting. You
could have saved me a lot of money on hotel and accommodation. No. I had to push back my time in Florida for this launch. Launches are so picky, y'all. They truly are just like, I think I'm going to launch a little later this week. Like just a little bit of cloud coverage here in the Bay Area would not do well. Lots of clouds here, but that Florida weather.
That's what you do. That's the hotels, maybe. Want to get to stay extra nights. Cool. So yeah, as you see, we got a few libraries imported here, and and the learn module will walk you through how to download everything that you use Anaconda. Get all the libraries downloaded. So we got some pandas here and NumPy, just some basic libraries for Python.
Vinny, are you able to zoom in a little bit? It looks like it's maybe a little bit small for folks. And what did you say the name of this database is?
So the database where we get all our data from is actually just an Excel document that we put together of some past launches.
Nice.
Yeah, let's see. How do you zoom this?
Ooh, are you on a Windows machine or a Mac?
Yes, I am.
On Windows?
Yeah, I'm on Windows, yep.
Let's see. Windows. Don't tell anybody I use a Mac. And you're using VS Code?
Yep.
Let's see. I think there's a shortcut that you can use, but I am a Mac queen, so let's see.
Zoom in. Okay. Is that better, or maybe a few more zooms?
A little more. Maybe one or two more. Come on and zoom. Come on and zoom. That looks a little better.
Looks good?
Yay.
Okay, cool. Yeah, if it needs to be zoomed anymore.
Control plus, apparently. Today I learned.
Wow.
I'm not weirdo at Microsoft with the Mac.
Yeah. Awesome. So yeah, so we got our environment switched over to the environment that has all the libraries downloaded, and then we'll run the first bit of code to actually import all these libraries. So yeah, we got the basic data manipulation libraries like Pandas and NumPy, and then we actually have some libraries to help us build all the machine learning models and everything. And then we also have some visualization that will show everybody, how it works with actual visuals instead of just the code and everything.
Pandas Great. And pythons, all the animals here today.
Yep, and then so we'll go ahead and actually import all the data here. So we'll call pandas.read Excel. Call that rocket launch data completed.
Let's see. Pandas is a new name for me.
You even heard about pandas?
It has been a while since I've used pandas. Now I'm like thinking of all these cute, cuddly critters. Well, I guess a python's not really cuddly. So when you were making this when you were making these learning paths, I should say, was it a little intimidating to be working on like NASA related stuff?
Yeah, in the beginning, my only, like before the internship, my only experience of NASA was like my 5th grade science class, where you learn about the planets and everything. So I was a little intimidated at first, but, coming into it, I talked to a lot of different NASA scientists, which was a great experience. And, they're all they just want to teach people and have them learn. So they were super, explained everything in great detail with us. So they were awesome. So yeah, so we have pandas to actually import all the data. So, we'll take a look at a little bit of it. So yeah, as you can see here, here's the Pioneer 3, which is a rocket that launched, looks like around December 6th at 1 o'clock from Cape Canaveral, which is a very common launch spot in Florida. And yeah, it looks like we got some different attributes of it, like if it was crewed or uncrewed, if it actually had a successful launch or not, the high temperature, low temperature, average temperature, and just a bunch of different attributes. And as you can kind of see, as you can kind of guess, like some of these might not be the best. So maybe the sea level pressure isn't really what we want. So we'll factor those out later. And also we've got a lot of null values, which we'll have to clean in a little bit.
I'm so excited. I feel like the magic of machine learning and AI is looking at a bunch of text like this and just being like, ugh, and then being able to actually predict something and create something out of it is just like a miracle.
Yeah, for sure. So yeah, so now we'll put some code in here to clean all the data. So as you can kind of see here, wherever there's no, like if we don't know if it launched or not, we're just going to go and say no for now because we want the conditions as ideal as possible. And then if it's crewed or uncrewed, we're just going to default to be uncrewed. And then yeah, a few other things for like wind direction, which might not make that big of a difference. We're just going to put unknown and condition just a general fair. So yeah, cleaning is a really essential process we have to employ to make sure the computer doesn't get confused with the data. If it sees a bunch of null data, it might get a little confused. And also another disclaimer, yeah, me too. Another disclaimer is, for this module, it's, as you can see, it's like a lot more things go into seeing if a rocket will launch than just these attributes. Yeah. So, this is just like a little taste of what they check. So, they have like weather balloons that go all the way up almost to space to check the weather up there. So yeah, this is just a little taste, just, looking at some general weather data.
I love data.
Yeah.
I'm such a weirdo who loves data. Like once I realized that I could play with and create really cool things with data, it completely blew my mind with computer science. I was like, you're saying that I can, well, actually there's a gal who I went to HackBright with, whose final project for HackBright was using all the UFO sighting data and mapping it on a visual heat map. And that was sort of what clicked for me of, oh, I can use all this data from different parts of the world and visualize it on a map. So whenever I think of, what we can learn from data and how we can kind of make it a pretty picture, I get so excited.
Yeah, and with all these different programming languages, it's so easy to take two different data sets and merge them together and find similarities, differences, and then you could use something like a machine learning pre-built algorithm to create a model. There's just so much stuff you can do with it.
Yeah.
So yeah, looking over here, we can see that all of our null values have been filled in, and now we've got some sparkly clean data here.
Ooh, pretty. So this is in I see. Okay. So now that we have all the data kind of cleaned,
Yeah.
what's our next step to tell our computer, like, hey, this is the information that we
Yeah,
want?
for sure. So now let's put this code in. So now, as you can see kind of here, like crewed or uncrewed, it's just text that says uncrewed. And the computers, they don't like strings. They work in binary, ones and zeros. So the next thing we're going to go into here is do something called a label encoder. And this is going to take all these different things and you just give them a number. So for example, if it's crewed, it's going to be a 1, and if it's uncrewed, it's going to be a 0. And depending on the wind direction, it'll give it like a number. And the same with condition. So that'll just make the computer be able to read this easier versus just reading in the different text, which that would also confuse it.
Yeah.
So we'll look here, and as you can see, oh, actually, so uncrewed is a 1. So now all the uncrewed have been transformed to 1s. And like the name, oh, never mind, the name's 0. So yeah, so wherever there was like strings is now numerical. So
nice. And I imagine that kind of helps with runtime as well. We're not having to sort.
Yeah, for sure, parse through everything. All right, awesome. So next, after now we have some clean data, we can go and break it into a training and a testing data set. So the training data set, as is kind of implied, is going to actually train our machine learning model. And then we're going to use the testing data set to actually test if this model works as expected. And we can access some things like accuracy and just see how well it does.
And I imagine that you always want to be careful on using the same training and testing data because, of course, it's going to work if the same data that you're training with, you're testing with. So having these two different environments is sort of essential to double, triple check, like, yes, it is working, and yes, it is working on the data beyond what I trained it on.
Yeah, and another thing that you need to do is, like, make sure that into these two groups is random. Because if you just, take a bunch of like, for example, if we only do rocket launches around the 1960s and put like on the same season, like all in summer, and we put all of those into the training data, then it's called overfitting. So it's going to know like way too much about the summer data. And then if we put like a winter month in or some low temperatures, it's going to be like, I don't know what the heck is going on here. So, taking a random sample of all your data to put in the training and testing groups is essential as well. Yeah. So and here we're separating it into, we're just going to take the launched category, which is what we want to be predicting, and separate that and put that into a variable called y, which these are very bad variable names, but in machine learning, this is really common practice to, have what we want to predict as a variable in y, and then have what we're predicting it with be an x. So yeah, we have the one we want to predict and y, and then we're going to just drop some unnecessary columns that we're not really interested in. So the computer doesn't really care about what the name is or what the time is. So you want to drop all these kind of like irrelevant columns and only have the columns that we want, like the temperature and stuff like that.
Someone just asked in the chat, is that Clippy 2.0 in the overlay? No, I wish. It's the MSLearn mascot. So it's kind of, maybe he's a relative of Clippy, but great question. I didn't wear my Clippy earrings today, but I did wear my floppy disk earrings that I got trolled the other day by a friend for saying they were save icon earrings. I promise I'm old enough to know what a floppy disk is.
I'm not.
So I have a question for you.
Yeah.
You said one of the things that we're removing is time, correct?
Yeah.
Now, would time have would it just sort of depend on what we're trying to figure out? Because time of day, would that maybe determine?
Yeah, for sure. That could be like, and this is all open to like experimentation. So maybe another time we'll keep time in there, and you can play around on your own, and just see what happens if we use time as a predictor as well. But I just think we were thinking, since we have like all the temperatures and stuff, which kind of is associated with time of day, like the computer wouldn't necessarily need to know like what time it is if it knows what temperature and stuff like that. But yeah, that could be another thing that would be interesting too, because like, do we want to not launch them at night or really early in the morning when there's, there might be fog in the morning or it's too dark at night to.
Yeah.
So yeah, that's something really interesting to look at. Cool. So yeah, as you can see here is what we're really looking at. So, some things like crude, the temperature, the precipitation. And like I said, you can play around with these, drop different columns on your own. For sure. So yeah, now we're actually going to be getting into the machine learning model that we're going to be using.
I'm so excited. I just got started with some AI machine learning myself, and it has been so fun to play around with because literally you're kind of holding the hand and training your machine with your data. It's so fun.
Yeah. So yeah, and it's so nice with all the different libraries. It makes it super easy where you just need to like scratch the surface a little bit of your learning, and from there you can make really cool things with a lot of the pre-made libraries and everything that people made. So in this, we're going to be making a decision tree, which it's pretty self-explanatory. It's just like a tree. So if a certain attribute is met on from the data, it'll go down that branch, and then once it gets down farther and farther, it'll start making decisions. So sorry, that was a little confusing. But yeah, so yeah, it's just like a tree structure. It's a very simple machine learning algorithm. So we will run that, and I'll show you a visual of it a little bit later. And so for random state and everything, like the max depth is how many like connections we're making between these different things. So 5 is not that high because there's probably, we don't want it to run for too long and make a lot of different connections. So yeah, so now we're going to actually separate our data into the testing and training sections. And here's where you really see that it's going to be like very random how we select the different data to be put in the test and train. And also you can see here that our test size is going to be only 20% of the data. So 80% of the data is going to be used for training. And we want a lot of this data to use to actually train the model. So we'll run that. So our data is now split, and now we are going to actually train the model. And this is called fitting the model. So we've got a bunch of different points if you picture on a grid, and we're trying to make the best line that fits, like encompasses all these points. So then we can put in different points and look on that line and see if the rocket will launch or not. So we're going to fit the model. Perfect. Now we're going to call the predict function on it. So this is the pre-built function, and it'll actually go through and just take all of this data. So crude or uncrewed for a certain day, the high temperature, precipitation, all of that, and then give us our y variable, which was if it launched or not. So awesome. So yeah, as you can see here, there's mostly no's. So for a lot of the different rocket launch that we analyzed, it was actually no. So the computer predicted that we should not launch on that day. So there's a few yeses here, and now we'll actually go to more of like an accuracy, because these numbers don't really tell us much. It just tells us if the rocket launched or not. But now we can actually look at the model and see how well that did. So we'll call tree model.score and put in our testing data of the test, and then what our machine predicted, which is stored in y-test. As you can see here, it's about 98%. So that's make our machine learning model making the predictions and then comparing that to what actually happened. So our machine learning model made 98% of the time it was making the correct guess. Cool. So now we're going to get into a little bit of visualization where you can see the kind of decision tree that I poorly explained before. So yeah, here we're just making a little function that is going to make the PNG picture. So we'll do that. And then we will call that function. Columns, values.
We're back. Let's see.
Were we down for a second?
I don't know. I think maybe you were live and I wasn't. I think.
Okay, I don't know. I just continued.
That's good. My Wi-Fi went miraculously. All right, we're back, baby.
All right. Hello. I do not know. I don't know where we left off here, but where the stream cut off. But so yeah, I guess I can just give a little brief summary of what we did.
Yeah, what I missed.
Cool. So we split everything. We have our decision tree imported, and we have that made. And then we're splitting our data into the training and testing groups, as we mentioned before. And you can see here, it's got a very randomness to it. So it's going to be really random. And then we're putting 20% of the data into the test bucket, the test data set, and 80% of the data into the training test, which is really essential because you want a lot of the data training your model, and then a little bit less in testing it. So after we have all the data separated, we're going to call the pre-made function, which is fit from our decision tree model with the training X and Y trains, and this is actually going to train our model. So it's going to go through and make all the different connections, and then yeah, we'll have the machine learning model created that we can actually make predictions from.
And look at how nice and clean this data is. Yeah.
Yeah, with the clean data. So yeah, now we're going to call the predict function, and this is going to give us, these are all of our tests. Like this is the 20% of the data that's in the test, and it's just going to print off yes or no, did the rocket launch or did the rocket not launch? So as you can see here, a lot of it is no.
Yeah.
Which is probably good to err on the side of caution. But we really don't know how accurate this is. We could have guessed, we could have said these are all no when they're really all yes. So we'll assess the accuracy of it by calling the score function here with the X and Y test.
I mean, as someone who had to go to a rocket launch that was delayed by 3 days, this data is feeling very relatable.
So yeah, we can see the accuracy of our model, which is 98%, which is really good.
Great.
Yeah. So what this kind of means is, our machine learning model predicted if the rocket would launch or not for a certain day, and then compared that to the actual data, if the rocket actually launched or not, and dividing those, you get 98%. So 98% of the time, the machine learning model predicted the correct outcome for the launch or not.
I'm so excited to use this on the next launch that I watch.
Yeah, for sure. And at the end, we have a little function that we create where you can, just put in all the weather data for the day that you're going, and it'll tell you yes or no, if you should go or not. So
we have a question in the chat here that says, "Is this Jupyter inside of VS?"
Yep, yeah, we're in VS Code right now. And after the live stream's over, I'll for sure put a copy of this on GitHub that you guys can take a look at.
Yay! Open source things.
Yeah, VS Code with the Python extension. So
gotta love it.
Convenient, very nice. So yeah, so now that we have the accuracy all completed, we're gonna work on visualizing it, which will actually show you the decision tree that I don't think I did justice explaining a few minutes ago.
Ooh, yay, I'm excited. You got a practice run before, so now is the real time.
Yeah, right. Cool. So yeah, this is going to make our decision tree.
Ooh.
So yeah, very pretty picture. And this is very simple, and the algorithm, the decision tree algorithm is just a great algorithm. It's very easy to understand. It's you either do this thing or you do that thing, which is perfect for our example because a rocket either launches or it doesn't. So you see here on the left side, there's going to be about 192 instances where the rocket did not launch, and then around 48 or 49 that actually instances of it where it did launch. So go down this side of the branch, and this actually also tells you if the machine learning model was successful or not. So it correctly identified that 191 rocket launches were delayed correctly. And then if you look over here, it tells you like the really identifying characteristic of it. So the max wind speed was less than 30 miles per hour, and that really warranted, like it's all good. Let's launch it. So yeah, this is how the decision tree works. It just goes down here and classifies, looks at the different attributes of everything, and makes a decision from that.
And as a visual learner, I love this piece because sometimes you can just look at the data and it can just feel like a lot, but being able to see it in this context, you're like, oh, okay, if this, then that.
Yeah, and this really tells you like the left side of the value is if it got like the number of it getting delayed, and the right side is the actual launch. So you can look at the different steps where it determines that. So yeah, it goes on this branch, and 191 times it fell right into here where it was getting delayed, and then 49 times it fell into here where 48 were successful and 1 got delayed. So yeah, it's a really cool visual.
Cool. And we've been able to spin this up pretty quickly, it seems.
Yeah. The whole process is really simple. If you have the data, just take it, clean it, and then call these pre-made libraries, which are really great. Cool. And so yeah, then the final thing I'll do, as promised, is make this little way that we can put some sample data in that we choose, and decide if the rocket should launch or not. So we're going to have our sample data here, data input, and then here are all the attributes that we can test or not. So see crewed or uncrewed, we'll put a 1. So that means uncrewed. We're testing it with a high temperature of 75, a low temperature of 68, average temperature of 71, and so on and so forth. And then with this data, we just call the predict function, and it'll tell us if it thinks the rocket will launch or not. So let's call this, and bam.
Wow.
That's a no. So
wow.
So yeah, so if so we can modify this a little bit and hopefully get to a launch.
Yeah.
But yeah, you can for sure play around with this at home and try to put in different data points, like what the temperature is currently at your location, and see if it will launch or not. So it's really fun to just play around with. So yeah, that's the end.
You could kind of simulate your own rocket launch, like I could
exactly.
in Oakland, where it's like, it looks foggy.
Yeah, right. So like turn the visibility down a little bit, and
very cool. So you mentioned that you got to talk with some NASA folks when you were putting this together. What were some of the things you either learned about launches or maybe about some of the technology in using this when you were putting this module together?
Yeah, for sure. Yeah, so I learned a lot of things. So as I said before, I made 3 different ones. So one is artificial intelligence about space rocks, and then this is the rocket launch. And the coolest thing I thought I learned about the rocket launch one was really that the rocket can get struck by lightning, and it glows up and it gets struck, as I said before. But also a few other things, like you really need to launch at places like Cape Canaveral that are really close to bodies of water, just in case of any emergencies, to make an emergency water landing. And also just like you need to take temperatures from around the globe, kind of, to see the different wind speeds at different places, the different temperatures, what weather is going to be coming in when the rocket is actually launching. So we just learned that there's so many things that go into deciding if a rocket will launch or not. And that's why this module really doesn't give justice to all the things that go into deciding if a rocket will launch or not, but it's just a really simple explanation to see.
Sure. We have some comments here.
Yeah.
One, so Sarah's asking, could a rocket launch on my birthday in my town? That's the question I would want to ask. That'd be really fun. You could like test the data based on like different weather from your birthday or like from a special occasion.
Exactly. Yep.
Yeah. And then we also have some folks in here talking about using VS Code, specifically using notebooks in VS Code for the first time. Cecil was saying he just used that for the first time. So fun. Let's see. And yes, we will definitely be tweeting out and sharing links to all of these modules on Learn. You know, in the meantime, I have a little space project that I could share. So we've been talking a little bit about specifically the different APIs and stuff that are available to folks out there. If you kind of want to get your hands on some of these NASA APIs, let's see if I can share my screen here. But I worked on a fun little project recently that's posted on Dev2. I will definitely link it in the notes here. Let's see. Okay, I'm going to actually figure out how to do this a little bit better. And I'm not going to spotlight myself. There we go. We're going to spotlight this there. So speaking of different data that's available for you to use, I worked on this fun little project with Azure Functions that actually uses, there's a library of images of Earth that are taken every single day. So you can get a picture of the Earth texted to you every day. It uses Azure Function timers. And it's really fun. It'll get your hands dirty a little bit with the Twilio API, using some NASA data as well. There's some picture here of some space food if that's important to you. But it'll walk you through here how to use an Azure Function app, just a really simple quick start tutorial, and all of the data that you need using the NASA API. Super, super simple. Really, you just have to generate a key for yourself and you're good to go. And yeah, definitely check that out.
Chloe, people are saying that they can't see you right now.
Oh, they can't? Oh, no. Really? Not even a screen share? Oh, no. Okay, well, I will stop sharing my screen. We'll go. How's that, everyone? Are we back? Sorry, y'all. We're having a technical difficulty today. I will share the link, but you can go to aka.ms/NASA functions, which I will make sure to drop in the chat here. Or you can check out the Dev2 post as well.
Oh, they're saying it's still not. Still can't see you.
Can you hear us, though? This is so strange. We can just see you. Okay, let's see. There's a giant me and a giant you. Okay, there we go. And how about now?
Do some magic.
It's the Vincent show.
Yeah.
Let's see. You know what, Vincent? How about you share your screen and we'll see if we can get it. We can get it up.
Okay. Share my screen of just anything, or?
Yeah, let's share your notebook again and we can take a look at that. Yeah,
for sure. I can also talk about the, maybe I'll show the other modules if you want to.
Yeah, let's do that. Let's see. How's this, y'all? Hopefully we're learning about machine learning. There we go. Now we're both on the screen. Sorry about that, y'all. I will share a link to that Dev2 link. But yeah, there's all sorts of fun NASA projects, different ways to use the libraries and APIs, and lots of just fun data. Just really fun data to be able to sort through. Either having to
hopefully
do with
we can share. Share some a lot of the different pictures of moon rocks too, which are really awesome.
We do love moon rocks.
So yeah, here I can.
And for this one, we are analyzing images of moon rocks to be able to identify them correctly.
Yeah. So this one is, like astronauts, when they go on the moon, they're probably not geologists, and their specialty is probably not focused is on like getting actually to the moon, and
right. They were focused on getting to the moon itself.
Yeah. So this second one is all about making it easier for the astronauts or rovers, so they could go up and take a picture of a moon rock, and it would tell them what kind of moon rock it is, and then they can determine, do I need this for my collection or do I not need this for my collection?
And that's great because that's basically using the same technology that we use even in a retail store, for example. Like instead of having to take inventory of every single item, being able to take a picture and properly classify and identify it, we can actually use that technology on rocks.
Yep.
Rocks. No pun intended.
Yeah, so for sure. So I can bring up a few pictures. Let's see if they'll come up here.
Rock on. Yes, I agree. Dynamite. Rock on indeed. All right, here's a picture of a rock.
Yeah, so here are some different pictures that you will be. These are like official pictures from NASA they'll be analyzing. So these are called basalt rocks, which come from the lunar volcanoes made these up, and this is like volcano
kind of like
rock.
A chicken nugget.
Yeah. And then
we're the untrained eye like us, we're like, okay, it's a rock. Cool.
Yeah, exactly. And like that's the struggle, it's like determining this from this thing. They look pretty similar. Like one's a little bit darker, but they're both pretty similar. They just look like rocks. So
and all of these images are just openly available to anyone, correct? So
correct. Yeah. People can just go peruse learn about some different rocks or make their own machine learning models.
Those of you at home who just, you're thinking, what do I do during shelter in place? Maybe look at some rocks, train some data on some rocks. We got you. NASA's got you.
Do this. So this module is really cool. It uses PyTorch, which is a pretty buzzwordy artificial intelligence machine learning library. And this one, you pretty much do the same process. You get the data in, you split the data into the training and testing, you clean it up a little bit, have all the images be the same size, print a few out, and then the finished product is going to be, the machine will guess which rock different pictures are. So and this one looks like it did pretty well here. So, this one, it guessed that this was a basalt and it said true. Guess this one was a basalt, true, and this one thought it was a highland, and it was false. So these are all basalts here, and it's really interesting just because machines are so good at determining those little minute details that the human eyes can miss. So that was kind of the inspiration for this one.
It's so interesting because we use machine learning on some of these very scientific things like rocks, for example, but then we can also apply this to other scenarios and other situations where maybe we don't have the time or energy to go through like 200 of the same piece of paper that we need to scan, or there's 200 different toys that I used to work in a toy store and we would do inventory management and have to go SKU by SKU and make sure that everything was accounted for. But what's cool with sort of this visual data that we're able to learn from is take a picture and we know. And the accuracy seems to be really, really
the accuracy for that one's good too. That's the whole idea of creating these different like machine learning and programming things in general. You just make it once and then you can apply it to different pictures and all that different stuff. It's really cool.
So people can go and check out these Learn modules for free starting this Thursday. We will link to all of the deets on those below so y'all can get your hands dirty with those. No pun intended. The rocks are clean. You don't have to touch the rocks or anything.
We've cleaned them already.
So this is the last week of your internship.
Yeah.
How are you feeling?
I'm sad. I don't know what I'm going to do.
You've been spending so much time on these amazing learning paths that are going to be played through and done by many people learning about space. What are maybe some things that you've learned about space or from your internship that you'd like to share? And I'll sing we can't pay for the rights, but I'll sing the graduation Vitamin C song as we go.
Yeah, it was just, such a great experience. I learned so much about, like, before the summer, I didn't even know anything about machine learning or artificial intelligence.
That's incredible. And you built out the whole thing.
Yeah, so I learned a lot, a little rough on some parts and talking about it, but yeah, it was just a great experience. Learned about machine learning and all that. I didn't even use Python before. At my school, it was all, Java and stuff. So even Python was new too.
That's
so all
great.
That was super cool. Yep.
So from knowing little to know nothing about Python, AI, ML, to building the Microsoft learning paths around them, I'd say pretty successful internship.
Yeah, pretty successful. And like I just learned about how great Microsoft Learn is. I use that for most of my learning, and so many different cool modules on there. I love the contextual ones. There's stuff like like determining different bird species with artificial intelligence, and something with polar bears, determining like where polar bears go, and it really got me inspired, and it was really fun actually learning about it. It's not just the boring, like this is a comment and all that stuff when you're usually learning about programming. So that made it really fun for me, and I really tried to put that into my modules. So hopefully you guys will enjoy them and be entertained.
And what I love about this is folks can go and play these modules and walk through them. It's all free. They have a sandbox environment to do it themselves. But what's really awesome and what I love to see, so please tag us/me on Twitter when you go through and play these, is how people end up repurposing them.
Yeah.
So specifically, I have, I'll share it in the notes as well below when we upload this on YouTube. But anything with the Face API, for example, doesn't have to stay in the genre. I do a Microsoft Face API Mario Kart astrology game, and people have repurposed it into other things other than Mario Kart. So I'm excited to see folks, first of all, getting their hands dirty with the NASA API, but then repurposing this module that you did to build all sorts of other fun things. Like, what if we predicted how likely it is that I wear my pink pair of glasses today, or how likely it is that I drink all of my cold brew this morning. There's so many different, visuals that we can add in here and ways that we can repurpose these. So if y'all are looking to get started with machine learning, this is a module you want to start with.
And also, like if you're just interested in NASA in general, in the years to come, Microsoft and NASA hope to release a lot more modules like this to really get people excited about programming through space. So check that out as well.
All the space things. And let's see. So there's a couple Learn modules that are coming out for you, right? We have the Moon Rocks one. We have the launch predictor. Is there another one as well?
Yeah, and then just like a learn to code in Python one. So if you're like me at the beginning of the summer, that'd be a good one to do.
So you really built these modules not only to help other people, but to help yourself learn.
Exactly.
Well, I think it just goes to show that it helped you. You were able to build all these awesome things with these modules. So.
Yeah, right. There's the proof.
So much fun. Let's see. We have some questions here in the chat. Do they do anything with machine learning for terraforming?
I don't think so yet, but that'd be a good request that we could talk to somebody about. And then the Mars, I think we're really going to launch some more with Mars in the future. So
fun. I've only been doing terraforming and Animal Crossing. Sorry, y'all. Haven't been doing much on Mars lately. Let's see, what other questions do we have in here? We have some people talking about rocks, of course. This project definitely rocks. I agree. I'm just so excited to play through these. What about asteroid mining?
That's kind of, we talk about that a lot in the Moon Rock one. We talk about what's the purpose of analyzing different space rocks. Like, what's the point? And asteroid mining is a really big reason for the future, at least. Right now, we're not there yet, but hopefully in the future we can get some really rare materials on Earth and find them in asteroids and other places in space, and take them for either fuel or some new technology to help us explore even more of space, or even find out that there's like water in some rocks and some forms of life somewhere out there. So
yeah, so exciting. I myself and Space Barbie will be completing these Learn modules as soon as they're out this Thursday. We'll definitely report back. Where can people find you on the interwebs, Vinny, if people want to check out your stuff?
Yeah, I should get some links ready. So yeah, I'm on LinkedIn and Twitter, and I do a little bit on GitHub, but we'll see. I don't know if I can send you my LinkedIn here.
And I'll, of course, be sharing out all the links for these Learn modules as they come out this week. Sadly, this is our last week with Vinny as an intern.
Yeah, I'm sad.
An emotional week as all of our interns leave us. But I really, truly do have to say, Vinny, these are incredible Learn modules. I am so excited and proud to play through them myself, and it rocks. It truly, literally, and figuratively.
Thank you so much. Rocks. It was so fun, and thanks to everybody that tuned in. It was a great live stream. It was like my first live stream ever. So thank you so much for asking all the questions and participating. So,
people are asking for Twitch handles. That's a great question. I think mine is Chloe Codes Things. I will be sure to drop it in here.
You should give them yours. I just made mine yesterday. I don't know.
Yeah, I will be maybe twitching some. I sound very old. I'll be twitching some crafty tech projects soon, but I will drop that in the comments. Chloe Codes Things, I believe is the name. Chloe Codes Things. And yeah, let's see. We've got a couple questions here that I think Sarah just answered. Do the moon rock images have metadata like from spectroscopy, or is the data spectroscopy, or is the data just set the image? This one's a little bit of metadata to help us train the model, but there's actually not a lot of metadata associated with the rocks because it's such a complicated process to collect them. Gotcha. Your facial features are being extracted for your first live feed.
I always wanted that to happen.
JK, but that was very funny, Nature Hermit. Alrighty. Well, any parting words? We've got a couple minutes here, Vinny, before we let you go.
Yeah, just thank yous. And if anybody else has some work they can give me when I'm after my internship, hit me up.
Yeah, he's very, very good at categorizing rocks and working with. No, but truly, all of our interns here are so incredible, and it's so bittersweet to see them all leave the nest. But I'm so proud, and I'm so excited to see the amazing things that you're going to get done out there in the world. And we've got Sarah is dropping your LinkedIn in here. She's your agent now, and yeah. I'm so excited to play through these. I think that, Microsoft Learn modules are already really fun. Like we said, we have these cool polar bear categorizing ones. We have these cool ones where you can categorize birds. As a space lover, she says, as she grabs all of her space things around her, I'm very, very excited to play through these because it combines two of my favorite things, learning a new skill and playing with space things. Alrighty. Well, I think that is about the end of the stream for us. Vinny, I will see you on the interwebs very, very soon.
Yep.
And we will be linking to all of these Learn modules this Thursday in the YouTube show notes on my YouTube page as soon as they're live. Have a great, great day, y'all, and we will see you on the interwebs.
Thank you guys so much. Thank you, Chloe.
Thank you.